Okay, so to finish this off, let's kind of summarize what's happening. Here's all of D4. We've like kind of gone through them all. So the center of D4 just has the identity in A squared. You can show that A squared, of course, A squared commutes with A, and A squared also commutes with B. Okay. So this is the center, and then your other possible conjugate classes are going to be these. And what we really want to show is that these two don't join up. In order to show these two, like we need to show that A is not conjugate to B, for example. So one way to show that they don't join up is to show that the number of elements in the conjugate is to remember the number of elements in the conjugate class of A equals the index of the stabilizer of A in G. And we'll write the stabilizer of C as C of A. No, that is kind of, we'll write the stabilizer as C sub G of A. That's maybe better. Okay, so therefore, if we compute the size of the centralizer of A, that tells us how many elements are in the orbit of A, or the conjugate class of A. So let's do that now. Okay, now we compute the elements of D4 such that GA equals AG. So we'll call this the centralizer in D4 of A. But notice A is in the centralizer of A, because A times A is just A times A. So this is like trivially satisfied. Okay. And so the centralizer is a subgroup. So all the powers of A are in the centralizer. Okay. But this means that, so D4 only has 8 elements. So this tells us that the centralizer has at least 4 elements. So from this, we have 2 possibilities. One possibility is that the centralizer is all of D4. And the other possibility is that the centralizer is just the subgroup generated by A. Okay. But if the centralizer of A is all of D4, that's just saying that A is in the center. So this would imply that A would be in the center of G, or the center of D4, which we know is not true. Like AB is not the same as BA. AB and BA are not equal. Okay, so this must be what's happening. And that implies that the, if we look at the index of the centralizer, right? That's just the number of elements of D4 divided by the number of elements of the centralizer. It's just 8 over 4, which is 2. So now the orbit stabilizer theorem tells us that this is the number of elements in the conjugacy class of A, 2 elements. And we already know that A and A cubed are conjugate to each other. So that's our conjugacy class. So therefore, A and A cubed is one conjugacy class, what about, now we have to do the same thing, but for the conjugacy class of B. Well, we could ask, what is the conjugacy class of B? Well, it turns out to be, well, definitely has the identity, definitely has B, definitely has A squared, since A squared is in the center. And so it also has to have A squared B. That's it. And the same kind of thing applies. It definitely has these 4 elements, but if it has anything more, then the centralizer would have to be the whole group, which would mean that B is in the center. B is not in the center, so this has to be the centralizer. This has index 2 in D4, so therefore another conjugacy class is B in a cubed B. And now the only things left are the remaining conjugacy class. So the last one is just AB. Oh, sorry, this should be B and A squared B. Sorry about that. And we have B and AB and A cubed B is the last one. Okay, so now the class equation for D4 is just 8 equals 2 plus 2 plus 2 plus 2. Okay, that's all. Okay, so when we say like write down the class equation for a group, we just mean find the number of elements in the center and find the size of each conjugacy class, and then just write this equation like that. That's all. Okay, so that is it for me today. I hope that oh yeah, and sorry, before you go quickly, just one quick announcement that so for the coursework exam is just gonna be 12 hours you have to do it. Okay, so I see there's something in the chat. Okay, yeah. I still have to figure out, what would be the best time to start at. Generally, I don't want it to start too early or go too late. I was thinking maybe like 10 a.m. to 10 p.m. But I could be convinced to do it at a different time as well. Okay, if you have any feelings, any particular feelings about what time it should start and end, please send me an email. You know, I don't want to disadvantage anyone in particular. Okay. So I guess that's it for today. Please try out the questions on the assignment and see how they go as well. Yeah, so that is it. Okay, thank you everyone also for watching.